Software is a set of computer programs and associated documentation and data. This is in contrast to hardware, from which the system is built and which actually performs the work. At the lowest programming level, executable code consists of machine language instructions supported by an individual processor, typically a central processing unit, CPU, or a graphics processing unit, GPU. Machine language consists of groups of binary values signifying processor instructions that change the state of the computer from its preceding state. For example, an instruction may change the value stored in a particular storage location in the computer, an effect that is not directly observable to the user. An instruction may also invoke one of many input or output operations, for example, displaying some text on a computer screen, causing state changes that should be visible to the user. The processor executes the instructions in the order they are provided, unless it is instructed to jump to a different instruction or is interrupted by the operating system. As of 2023, most personal computers, smartphone devices, and servers have processors with multiple execution units, or multiple processors performing computation together, so computing has become a much more concurrent activity than in the past. The majority of software is written in high-level programming languages. They are easier and more efficient for programmers because they are closer to natural languages than machine languages. High-level languages are translated into machine language using a compiler, an interpreter, or a combination of the two. Software may also be written in a low-level assembly language that has a strong correspondence to the computer's machine language instructions and is translated into machine language using an assembler. On virtually all computer platforms, software can be grouped into a few broad categories. Purpose, or domain of use. Based on the goal, computer software can be divided into: application software uses the computer system to perform special functions beyond the basic operation of the computer itself. There are many different types of application software because the range of tasks that can be performed with a modern computer is so large. See list of software. System software manages hardware behavior, as to provide basic functionalities that are required by users, or for other software to run properly, if at all. System software is also designed for providing a platform for running application software, and it includes the following. Operating systems are essential collections of software that manage resources and provide common services for other software that runs on top of them. Supervisory programs, bootloaders, shells, and Windows systems are core parts of operating systems. In practice, an operating system comes bundled with additional software, including application software, so that a user can potentially do some work with a computer that only has one operating system. Device drivers operate or control a particular type of device that is attached to a computer. Each device needs at least one corresponding device driver, because a computer typically has at minimum at least one input device and at least one output device. A computer typically needs more than one device driver. Utilities are computer programs designed to assist users in the maintenance and care of their computers. Malicious software, or malware, is software that is developed to harm or disrupt computers. Malware is closely associated with computer-related crimes, though some malicious programs may have been designed as practical jokes. Nature or domain of execution. Desktop applications such as web browsers and Microsoft Office and LibreOffice and WordPerfect, as well as smartphone and tablet applications, called apps. JavaScript scripts are pieces of software traditionally embedded in web pages that are run directly inside the web browser when a web page is loaded without the need for a web browser plugin. Software written in other programming languages can also be run within the web browser if the software is either translated into JavaScript, or if a web browser plugin that supports that language is installed. The most common example of the latter is ActionScript scripts, which are supported by the Adobe Flash plugin. Server software, including web applications, which usually run on the web server and output dynamically generated web pages to web browsers, using e.g. PHP, Java, ASP.NET, or even JavaScript that runs on the server. In modern times these commonly include some JavaScript to be run in the web browser as well, in which case they typically run partly on the server, partly in the web browser. Plugins and extensions are software that extends or modifies the functionality of another piece of software, and require that software be used in order to function. Embedded software resides as firmware within embedded systems, devices dedicated to a single use or a few uses such as cars and televisions, although some embedded devices such as wireless chipsets can themselves be part of an ordinary, non-embedded computer system such as a PC or smartphone. In the embedded system context there is sometimes no clear distinction between the system software and the application software. However, some embedded systems run embedded operating systems, and these systems do retain the distinction between system software and application software, although typically there will only be one fixed application which is always run. Microcode is a special, relatively obscure type of embedded software which tells the processor itself how to execute machine code, so it is actually a lower level than machine code. It is typically proprietary to the processor manufacturer, and any necessary correctional microcode software updates are supplied by them to users, which is much cheaper than shipping replacement processor hardware. Thus an ordinary programmer would not expect to ever have to deal with it. Programming tools are also software in the form of programs or applications that developers use to create, debug, maintain, or otherwise support software. Software is written in one or more programming languages. There are many programming languages in existence, and each has at least one implementation, each of which consists of its own set of programming tools. These tools may be relatively self-contained programs such as compilers, debuggers, interpreters, linkers, and text editors, that can be combined to accomplish a task, or they may form an integrated development environment, IDE, which combines much or all of the functionality of such self-contained tools. IDEs may do this by either invoking the relevant individual tools or by re-implementing their functionality in a new way. An IDE can make it easier to do specific tasks, such as searching in files in a particular project. Many programming language implementations provide the option of using both individual tools or an IDE. People who use modern general-purpose computers, as opposed to embedded systems, analog computers, and supercomputers, usually see three layers of software performing a variety of tasks: platform, application, and user software. Platform software: the platform includes the firmware, device drivers, an operating system, and typically a graphical user interface which, in total, allow a user to interact with the computer and its peripherals, associated equipment. Platform software often comes bundled with the computer. On a PC one will usually have the ability to change the platform software. Application software: application software is what most people think of when they think of software. Typical examples include office suites and video games. Application software is often purchased separately from computer hardware. Sometimes applications are bundled with the computer, but that does not change the fact that they run as independent applications. Applications are usually independent programs from the operating system, though they are often tailored for specific platforms. Most users think of compilers, databases, and other system software as applications. User-written software: end-user development tailors systems to meet users' specific needs. User software includes spreadsheet templates and word processor templates. Even email filters are a kind of user software. Users create the software themselves and often overlook how important it is. Depending on how competently the user-written software has been integrated into default application packages, many users may not be aware of the distinction between the original packages and what has been added by coworkers. Computer software has to be loaded into the computer's storage, such as the hard drive or memory. Once the software has loaded, the computer is able to execute the software. This involves passing instructions from the application software, through the system software, to the hardware which ultimately receives the instruction as machine code. Each instruction causes the computer to carry out an operation moving data, carrying out a computation, or altering the control flow of instructions. Data movement is typically from one place in memory to another. Sometimes it involves moving data between memory and registers which enable high-speed data access in the CPU. Moving data, especially large amounts of it, can be costly. This is sometimes avoided by using pointers to data instead. Computations include simple operations such as incrementing the value of a variable data element. More complex computations may involve many operations and data elements together. Computer software has to be loaded into the computer's storage, such as the hard drive or memory. Once the software has loaded, the computer is able to execute the software. This involves passing instructions from the application software, through the system software, to the hardware which ultimately receives the instruction as machine code. Each instruction causes the computer to carry out an operation moving data, carrying out a computation, or altering the control flow of instructions. Data movement is typically from one place in memory to another. Sometimes it involves moving data between memory and registers which enable high-speed data access in the CPU. Moving data, especially large amounts of it, can be costly. This is sometimes avoided by using pointers to data instead. Computations include simple operations such as incrementing the value of a variable data element. More complex computations may involve many operations and data elements together. Software engineering is an engineering-based approach to software development. A software engineer is a person who applies the engineering design process to design, develop, maintain, test, and evaluate computer software. The term programmer is sometimes used as a synonym, but may emphasize software implementation over design and can also lack connotations of engineering education or skills. Engineering techniques are used to inform the software development process, which involves the definition, implementation, assessment, measurement, management, change, and improvement of the software lifecycle process itself. It heavily uses software configuration management, which is about systematically controlling changes to the configuration, and maintaining the integrity and traceability of the configuration and code throughout the system lifecycle. Modern processes use software versioning. Notable definitions of software engineering include the systematic application of scientific and technological knowledge, methods, and experience to the design, implementation, testing, and documentation of software. The Bureau of Labor Statistics IEEE Systems and Software Engineering, vocabulary. The application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. IEEE Standard Glossary of Software Engineering Terminology. An engineering discipline that is concerned with all aspects of software production. Ian Somerville. The establishment and use of sound engineering principles in order to economically obtain software that is reliable and works efficiently on real machines. Fritz Bauer. A branch of computer science that deals with the design, implementation, and maintenance of complex computer programs. Merriam-Webster. Software engineering encompasses not just the act of writing code, but all of the tools and processes an organization uses to build and maintain that code over time. Software engineering can be thought of as programming integrated over time. Software engineering at Google. The term has also been used less formally as the informal contemporary term for the broad range of activities that were formerly called computer programming and systems analysis. As the broad term for all aspects of the practice of computer programming, as opposed to the theory of computer programming, which is formally studied as a subdiscipline of computer science. As the term embodying the advocacy of a specific approach to computer programming, one that urges that it be treated as an engineering discipline rather than an art or a craft, and advocates the codification of recommended practices. Requirements engineering is about the elicitation, analysis, specification, and validation of requirements for software. Software requirements can be of three different types. There are functional requirements, non-functional requirements, and domain requirements. The operation of the software should be performed and the proper output should be expected for the user to use. Non-functional requirements deal with issues like portability, security, maintainability, reliability, scalability, performance, reusability, and flexibility. They are classified into the following types: interface constraints, performance constraints, such as response time, security, storage space, etc., operating constraints, life cycle constraints, maintainability, portability, etc., and economic constraints. Knowledge of how the system or software works is needed when it comes to specifying non-functional requirements. Domain requirements have to do with the characteristic of a certain category or domain of projects. Software design is about the process of defining the architecture, components, interfaces, and other characteristics of a system or component. This is also called software architecture. Software design is divided into 3 different levels of design. The 3 levels are interface design, architectural design, and detailed design. Interface design is the interaction between a system and its environment. This happens at a high level of abstraction along with the inner workings of the system. Architectural design has to do with the major components of a system and their responsibilities, properties, interfaces, and their relationships and interactions that occur between them. Detailed design is the internal elements of all the major system components, their properties, relationships, processing, and usually their algorithms and the data structures. Software construction, the main activity of software development, is the combination of programming, unit testing, integration testing, and debugging so as to implement the design. Testing during this phase is generally performed by the programmer while the software is under construction, to verify what was just written and decide when the code is ready to be sent to the next step. Software testing is an empirical, technical investigation conducted to provide stakeholders with information about the quality of the product or service under test, with different approaches such as unit testing and integration testing. It is one aspect of software quality. As a separate phase in software development, it is typically performed by quality assurance staff or a developer other than the one who wrote the code. Software analysis is the process of analyzing the behavior of computer programs regarding a property such as performance, robustness, and security. It can be performed without executing the program, static program analysis, during runtime, dynamic program analysis, or in a combination of both. Software maintenance refers to the activities required to provide cost-effective support after shipping the software product. Software maintenance is modifying and updating software applications after distribution to correct faults and to improve its performance. Software has a lot to do with the real world, and when the real world changes, software maintenance is required. Software maintenance includes error correction, optimization, deletion of unused and discarded features, and enhancement of features that already exist. Usually, maintenance takes up about 40% to 80% of the project cost. Therefore, focusing on maintenance keeps the costs down. Knowledge of computer programming is a prerequisite for becoming a software engineer. Many software engineers enter the profession by obtaining a university degree or training at a vocational school. In addition to university education, many companies sponsor internships for students wishing to pursue careers in information technology. These internships can introduce the student to interesting real-world tasks that typical software engineers encounter every day. Similar experience can be gained through military service in software engineering. Half of all practitioners today have degrees in computer science, information systems, or information technology. A small, but growing, number of practitioners have software engineering degrees. Legal requirements for the licensing or certification of professional software engineers vary around the world. Many software engineers work as employees or contractors. Software engineers work with businesses, government agencies, civilian or military, and non-profit organizations. Some software engineers work for themselves as freelancers. Some organizations have specialists to perform each of the tasks in the software development process. Other organizations require software engineers to do many or all of them. In large projects, people may specialize in only one role. In small projects, people may fill several or all roles at the same time. Many companies hire interns, often university or college students during a summer break, or externships. Specializations include analysts, architects, developers, testers, technical support, middleware analysts, project managers, software product managers, educators, and researchers. The Software Engineering Institute offers certifications on specific topics like security, process improvement, and software architecture. IBM, Microsoft, and other companies also sponsor their own certification examinations. Many IT certification programs are oriented towards specific technologies, and managed by the vendors of these technologies. These certification programs are tailored to the institutions that would employ people who use these technologies. Broader certification of general software engineering skills is available through various professional societies. Thank you for watching this video.